All right, if you're like me, you love the law of sines, you set up the ratio, you plug stuff in, you just get your answers so quick. It's not that difficult to set up and everything. We've looked already at angle side and angle situations. The time that we can use the law of sines, but at the same time we can't, is if we have side angle. Remember from geometry, side angle was always a problem for us. And side angle does pose a few problems for us when we're looking at triangles, trying to use the law of sines. So the time that it will work for us, all right, if we have been given an obtuse angle, we set up our triangle as seen here. If we have an obtuse angle, either it's going to work or it's not. It's that simple. We're either going to be able to plug it in and we're going to get a solution that's going to make sense, or we're going to plug it into our calculator and we're going to get no solution because we're going to end up trying to take the inverse sign of something outside of that -1 to +1. And so let's look at this. If we set up the law of sines in this situation, it would be sine of 94 over 15 sine of c over 12. We cross multiply, we solve for c. I think we know how to cross multiply at this point. We get about 52.94 degrees would be C. We use that to find B. Sorry, it says round angle measures to the nearest degree, so I'm just going to go 53 degrees. That is what it wants from me there. So that would leave angle B to be about 33 degrees. We could then use the law of sines one more time to find B. Notice how this works. It gave us an actual solution. All of that was nice. And we were given an obtuse angle to play with at the beginning there. One more time, law of sines. And I get about, I won't round to the nearest tenth, 8.2 there, about 8.2. All right, so let's see another situation. All right, once again, we've been given the side angle situation. If we set this up, triangle ABC, angle A is 61, opposite A is 9, opposite B is 11. We have an acute angle this time, so we are going to see where this goes. And if I just set this up, sine of 61 over 9 equals sine of B over 11. I get sine of B is equal to 1.07, and so when I take the inverse sine of both sides to find B, notice I'm going to be taking the inverse sine of a number greater than 1, and if I do that, notice I get an error in my domain. That is a problem because I know I can't take the sine of a number bigger than 1. This right here, no solution. AKA, there's no triangle possible with those criteria right there. So most interesting enough is when we're given side angle one more time. In this case right here, A is 43 degrees, opposite A is 25, B is 28. Notice how it says find two triangles for which this is possible. If we're given side-side angle, there could be no solution. There could be one solution. There could be two possible triangles sometimes. To have two possible triangles, we have to be given an acute angle to begin with. The angle we've been given, opposite that angle, is a value smaller than the side length that's opposite the angle that we're looking for. This situation right here, we're given an acute angle, and the two sides we have, the one opposite our acute angle is smaller than the other side. In this situation, there's always going to be two possible solutions. So, if we play this out, well, I guess there's not always that value could be too big to be a possible triangle. But if this works to get us a value for b right here, if there is a solution, there's two possible solutions. So if I work this out, 28 sine of 43, 5 by 25, it wants me to round to the nearest degree. B would be about 50 degrees. And well, we can keep playing this triangle out right here because we got that 50-degree angle. We subtract those from 180. This would be 87. We do one more law of sines. Sine of 43 over 25 equals sine of 87 over c. And we get about 36.6. So this is one possible solution right there. All right, now I'm going to erase this work. I'm going to keep that triangle up there because here's the other possible thing. All right, remember the situation. We start with an acute angle, and the two sides we had, the one we knew that was opposite our acute angle was smaller than the other one. All right, and we got a solution for this. Well, the other triangle that's possible is that angle B could actually be obtuse. So same situation, A is still 43. We got 25 here, we have 28 over here. Well, B could be obtuse. Basically, here's the grand scheme of things. Here's our two possible triangles. We have this big one here, where this is angle A, this is angle C, here's angle B. That was the first one we worked through. Or it could be down here, where angle B is actually this angle, which would have to be 130 degrees because of that linear pair right there. So you subtract 50 from 180, and that would have to be 130 degrees, leaving C right here to be just 7. But the larger C was 87, if you remember. So this is a much smaller piece that we're looking for because angle B is actually obtuse. Remember, it could be obtuse because that could be the longest side of the triangle. Here we were just assuming C was the longest side, but it could be B that was the longest side. That's the problem with having B being larger than A. So if I work this out, I can do one more law of sines. Sine of 43 to 25 is equal to sine of 7 over C. And we get 4.5. Could just be 4.5. 5 right there. So that is a little confusing. There's some diagrams in the book that might help. But if, again, the situation that causes two triangles, we had an acute angle and the side opposite our angle is smaller than the other side that we were given.